Yes.
Okay. Okay. So in this session, we'll be talking about wireless protocols for IoT. So when it comes to wireless protocols, there could be personal area networks, like which those wireless protocols that caters to smaller regions, and then there could also be wide area networks. So IoT is capable of working with both like constrained bandwidths as well as highly available bandwidths like our normal HTTPS and our internet protocols. So accordingly, there are.
Sukanya, your voice is not coming properly.
Is there a background noise? Is there a background noise?
Now, am I audible correctly? Okay, it's clearly audible. Thanks. So when it comes to wireless protocols, there are quite a few wireless protocols that are prevalent nowadays, and we do keep using those for various applications. I mean, of course, the choice of wireless protocols varies basis application requirement, but nonetheless, we do have smart home solutions, smart things like smart fridge, smart switches, all of these working wirelessly. And talking about industrial IoT, that means IoT on a larger scale. We have heavy machineries which are connected, which are heavy machineries. That means IoT on a larger scale. We have heavy machineries which are connected. Sorry, sir, you would need to go on mute. Heavy machineries. That means IoT on a larger scale. We have. Yeah. So yeah. So we do, when it comes to industrial IoT, we have manufacturing units and heavy machineries connected through sensor over network, and those typically use the general. I mean, within factories, they might just use low personal area networks. Like it could be MQTT, it could be Zigbee, it could be. I didn't know Bluetooth, but mostly MQTT does the job. And when it has to transmit data over internet, then of course it goes for the general Wi-Fi or the HTTP protocols, HTTPS protocols. Like consider for a supply chain use case, you have trucks connected with sensors, and those vehicles are on road and giving you real updates. Then those data from those sensors are collected, and the data from those sensors are collected, and you know, and immediately transmitted to the central server for real-time monitoring and dashboarding, right? So that's that. Anyway, we'll cover more examples as and when we cover scenarios, but for now, let's look at what we have. Well, first and foremost, we have Bluetooth. Bluetooth is definitely an important short-range communication technology, and so it's mostly for personal area network, and which has become very important in computing and many consumer product markets. So uh, even Bluetooth has found its profound significance in use cases, in smart product use cases. Let's say, so you consider, I mean, there has been applications in US and UK where people have used Bluetooth technology for smart buyer's option. Like, imagine a superstore, imagine a supermarket, a departmental store where you get in, you are given a BLE device, and every product that you collect gets registered to that BLE device. And once you come out of the store, you don't need to stand in queue. You just register, you just swipe that BLE device, and it automatically calculates the amount, and the amount gets deducted from your account if you are connected, if your account is connected to that store. So that's an example of using wireless IoT connectivity for an industrial use case, for a smart shopping use case, right? So Amazon has done such things. Using Amazon Pay, you can just automatically, like, just pay and come out of the store. You don't need to swipe your cards or something of that sort. Then there's then a store, then a supermarket chain in UK has done this BLE implementations, wherein they track the move. Not they track. They do keep a note of the products as well as the consumers who take it, and then while on the payment line, there's not much queue. It all happens on a semi-automatic or a fully automatic manner. So, and then there are conferences that have enabled mm, that have enabled Bluetooth. Sorry, RFID. RFID is another mode of wireless communications that have enabled RFID tags in your ID card. So once you get into the conference, when you register for the conference, you get an ID card, right? They have enabled RFID tags to understand the user behavior, for like which session is having many users, many attendees, which session is not having attendees, like to understand user behavior in terms of the sessions offered on the conference. Anyway, so okay, so getting back to what Bluetooth is, so basically, of course, Bluetooth is expected to be the wearable product. I mean, even your smart watches, right? Your smart watches are capable of are enabled with Bluetooth that tracks activity from your body and transmits it from your smartphones, right? So wearable devices, of course, are expected to be the key players of Bluetooth. Then of course, the new Bluetooth Low Energy, or the Bluetooth Smart, as it is now branded. So basically, versions 4 and above has significantly contributed to the IoT applications. Importantly, while it offers also similar range to Bluetooth, it has been designed to significantly significantly reduced power consumption. So the latest version of Bluetooth consumes significantly low power than the previous versions of Bluetooth. That is extremely important because IoT devices are embedded devices, small devices, and they are not so power hungry, and it is often not possible for them to produce that much amount of power. Okay. However, one thing to note is that Smart BLE is not really designed for file transfer, and it is more suitable for small chunks of data. It has major advantages, certainly in a more personal device context over many competing technologies, given its widespread integrations in smartphones and many other mobile devices. According to the Bluetooth Special Interest Group, more than 90% of Bluetooth-enabled smartphones, including iOS, Android, and Windows-based models are expected to be smart ready. Of course, by 2028, and we now see 2021, we have seen the enormous development in smartphones, in smart wearables, and soon we'll see immense amount of improvement in wearable health devices that are like just like shape of a tablet could get into your body and could could help doctors understand the symptoms better. I mean, for that, possibly Bluetooth or some other modes of communications, wireless mode of communications could be utilized. But yeah, I mean, that pretty much boils down to another use case. Anyway, devices that employ Bluetooth smart features incorporate the Bluetooth code specification version 4.0, and now we have Bluetooth 5.0, of course, or higher. The latest, I mean, this blog post is a little old. Okay, so now we have pretty much Bluetooth 5.0 up and running. Okay, so then which combine with a combined basic data rate and low energy core configurations of a RF transceiver baseband and protocol stack. Importantly, version 4.2 via its internet protocol support profile will allow Bluetooth smart centers to access the internet directly via 6LoWPAN connectivity. 6LoWPAN is another wireless connectivity protocol. So version 4.2 and above has the capability of connecting Bluetooth devices over internet through 6LoWPAN. The IP connectivity makes it possible to use existing IP infrastructure to manage Bluetooth Smart Edge devices. More information on Bluetooth 4.0 could be available here. Anyway, this is not accessible. And a wide range of Bluetooth modules also are available. So we essentially at the tinkering level, we use HC05. Like when I say tinkering level, that means for prototyping purpose, we use modules like HC05 with Arduino or HC010, sorry, HM10. These modules are typically used with Arduino. When it comes to Node MCU, that means ESP8266 modules, that has Bluetooth and Wi-Fi inbuilt. Same goes for Raspberry Pi, that has Bluetooth and Wi-Fi inbuilt. So some standard specifications of Bluetooth are like it has a frequency of 2.4 gigahertz ISM. I think Bluetooth 5.0 is also coming with a bandwidth of 5 gigahertz. Range is generally typically between 50 to 150 meter, but for Bluetooth 5.0 it's a little more. Data rates are like close to 1 Mbps. I mean, when it comes to edge devices, it pretty much solves the need of for 1 Mbps transfer, given that we are having another device stored for storing the data. But if it has to, I mean, Bluetooth is not capable of transferring data over long range. This is something that needs to be kept in mind. Okay. Now there's another protocol called Zigbee, and the module as in the hardware module that caters to this protocol is the XB module. Okay, so Zigbee, much like Bluetooth, has a large installed base of operations. Zigbee is definitely used widely nowadays. Even for some home automation purposes, Zigbees are widely used, although perhaps traditionally more in an industrial settings. Zigbee Pro and Zigbee Remote Control, among other available Zigbee profiles, are based on this protocol, IEEE 802.15.4 protocol, which is an industry standard wireless network technology operating at 2.4 gigahertz. So our internet mostly operates at 2.4 gigahertz, and nowadays we get dual band with 5 gigahertz as well. Okay, now of course this targets applications that requires relatively infrequent data exchange at low data rates over restricted areas. So let's say you have a sensor network for disaster prediction you have a sensor network for disaster predictions uh, installed in a very remote area. Okay, and you are not collecting a massive amount of data. Uh, so in that case, we could definitely use Zigbee. One thing to remember is Zigbee is relatively useful for infrequent data exchange at low data rates. Then Zigbee or RF4CE has significant advantages in complex systems, offering low power operations, high security, robustness, and high scalability with high node counts, and is well positioned to take advantage of wireless control and sensor networks in M2M and IoT applications. So, Zigbees are typically used where we require low power operations in a highly secured, robust, and highly scalable environment. Okay, with multiple node counts. Node counts could be the sensor nodes, uh, or 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 in case of an M2M communications, could be other M2M nodes, which are well positioned to take advantage of the wireless control and sensor networks. In case of an M2M setup, or an M2M is nothing but machine to machine setup, or an IoT applications. Okay, so Zigbee is openly available, and Zigbee has a consortium uh, that maintains the development of Zigbee. Anyway, so Zigbee 3 and above right now, it's based on protocol IEEE 802.15. Frequency is 2.4 gigahertz. Range is 10 to 100 meter. Data rate is 250 kbps, lesser than Bluetooth. Now ZWave, that's why Zigbee is ideal for a low memory microcontroller transfers infrequent amount of data. Anyway, so then we have ZWave. So the ZWave is a low power RF communication technology that is primarily designed for home automation for products such as lamp controllers and sensors, among many others. Optimized for reliable and low latency communications of small data packets with data rates up to 100 kilobytes per second. It operates in the sub 1 gigahertz band and is impervious to interference from Wi-Fi and other wireless technologies, which is operating in the range of 2.4 gigahertz, just Bluetooth or Zigbee. That means, first of all, Z-Wave is low power. It's a radio frequency communication technology. Okay, and well, not used much for industrial applications. But if you find, if you have any small applications that caters to just like a short distance, then you could use Z-Wave for your applications. But ideally, not used much for any kind of industrial applications. Anyway, so it is optimized for reliable and low latency communications for small data packets, which has data rates of 100 kilobytes per second, and it operates in the range of 1 gigahertz band, and it cannot be. I mean, there are other wireless communication protocols such as Wi-Fi working at 2.4 gigahertz, and Bluetooth and Zigbee working at the same time. It usually does not uh, uh, overlap over one another. The range does not overlap over one another. Okay, and then Z-Wave is also capable of supporting full mesh networks without the need for a coordinator node, and of course is very scalable. So mesh networks are nothing but sensor networks, multiple sensors connected to the networks. Okay, and this also enables control of up to 232 devices. Z-Wave uses a similar protocol than some others. Uses a simpler protocol than some others like Bluetooth and Zigbee, which basically enables faster and simpler development. But there's just one maker of chips, which is Sigma Designs. Although we don't use Z-Waves much unless it is, as I said, it is in a short range communication mode. All right. So standard Z-Wave, there's an alliance that maintains this protocol. Frequency is 900 megahertz. Range it could operate up to is 30 meter, and data rates could, it's just like 9.6, 40 or 100 kilobytes per second. Then there's something called 6-low-PAN. So what happens here is it's 6-low-PAN, as we said, like here while covering Bluetooth, we covered that uh, very briefly, but here a little bit elaborate. So 6-low-PAN is basically a key internet protocol, uh, IP, so internet protocol based technology, and it basically stands for IPv6, a low power wireless personal area network. So rather than being an IoT application protocol technology, just much like Bluetooth or Zigbee, 6-low-PAN is basically a network protocol at the network level that defines the encapsulations and header compression mechanisms. The standard has the freedom of frequency band and physical layer, and can also be used across multiple communication platforms, including Ethernet, Wi-Fi, 802.15.4, and sub 1 gigahertz ISM. So it could be used in cross interpolations with a lot of other bands as well. A key attribute of IPv6 stack is basically a very basically the introductions. I mean, so over the years, as we have IPv6, that I mean IPv6 would generally be the protocol for any internet devices acting over internet, because IPv6 has the capability of dynamically generating IP, and IPv6 was created to not run out of IPs, whereas IPv4 has its own limitations. So of course, one key attribute of 6-low-PAN is the introductions of IPv6 protocol that generally enables the uh, IoT devices getting registered, multiple, actually millions of IoT devices getting registered on a network. Anyway, IPv6 is the successor of IPv4, as we know, which offers approximately 510 to the power 28 address for every person in the world. That's huge. That the probability of that is huge, enabling any embedded objects or devices in the world to have its own unique IP address and connect to the internet. So even if, I mean, basically, when it comes to the definition of internet, even when it internet of things, these things comprise of anything. It could be us, like even if you carry an RFID tag, we can be located and we become things, right? And then there is anything, any animals, any objects, any devices, everything becomes a things in the internet of things, or the connected era, basically. Even we as humans will be located using uh, a URI. URI is Uniform Resource Identifier, which will act as our digital identifier address on the internet, and we could be located using that. Anyway, so 6-low-PAN is especially designed for home or building automation. For example, IPv6 provides a basic transport mechanism to produce complex control systems and to communicate with device in a cross-effective manner via low-power wireless network. Also, 6-low-PAN is designed to send IPv6 packets over IEEE 802.1.15.4 based networks, and implementing those open IP standards, which includes TCP, UDP, HTTP, COAP, MQTT, and WebSockets. The standard offers end-to-end addressable nodes, allowing a router to connect to network to IP. Then the 6-low-PAN, I mean, low power wireless personal area network is basically a mesh network, as I described. Mesh network is nothing but multiple sensors. Let me see if I can get up a Google of image of sensor mesh network. It looks like this. Like mesh is basically multiple devices. So consider each of these nodes as devices. Ideally like something like this. So 6LoWPAN is capable of 6LoWPAN is capable of catering to mesh networks that is robust, scalable, and self-healing. Robust, you understand, is quite robust. It is capable of accommodating a number of devices. It is also scalable, so when new devices get added, it can scale on its own. And self-healing, which means that if there are any issues on the network level, it can heal on its own and start operation in its normal form. Anyway, mesh router device can route data designed for other devices, while hosts are able to sleep for long periods of time. And explanations of 6LoWPAN is available here.
Hello.
I can send you this video and you can have a look. Anyway, standard is RFC 6282. Frequency is much like Bluetooth Smart, which is 2.4 gigahertz, or Zigbee or low power radio frequencies, which is in the sub 1 gigahertz bandwidth. Range not applicable, data rates not applicable. It can, since it is IPv6 and it basically implements over IP protocols like TCP, UDP, HTTP, so it can work over any range. So that shouldn't be a challenge. Thread. Thread is another protocol, but okay. So basically, not much use now. Anyway, a very this is basically a new IP-based IPv6 networking protocol aimed at the home automation environment. So based on the 6LoWPAN, and also similar to it, it is not just an IoT applications protocol. It is mostly from an application point of view, and is primarily designed as a complement to Wi-Fi, as it recognizes that whole Wi-Fi is good for many consumers devices, that it has limitations for use in a home automation setup. Launched in basically mid 2014 by the Thread group. This is a royalty-free protocol and is based on various standards, including IEEE 802.15.4 as the wireless air interface protocols. Also, it is based on IPv6 6LoWPAN and offers resilient IP-based solutions for the IoT. Designed to work on existing IEEE 802.15.4 wireless silicon from chip vendors, just Freescale and Silicon Labs. Thread supports a mesh network using IEEE 802.15.4 radio transceivers and is capable of handling up to 250 nodes with high levels of authentication and encryption. Relatively simple software upgrade should allow users to run Thread on existing IEEE 802.15.4 enabled devices. So the standards are pretty much the same. It uses Thread based on IEEE 802.15.4 and 6LoWPAN. Frequency is 2.4 gigahertz, much like normal internet. There is no range available, as again it is IPv6 enabled, and there are no data rates available. Anyway, now coming to the much used Wi-Fi and the cellular networks. Okay. So Wi-Fi connectivity is often an obvious choice for many developers, especially given the pervasiveness of Wi-Fi within the home environment, within LANs. it also requires a little more explanations, except to state the obvious that basically it's a clear, it's a wide area network, and of course, for Wi-Fi at this present moment, there are existing infrastructures, quite stable infrastructures as well, offering uh, extremely fast data transfer and the ability to handle high quantities of data. Currently, the most common Wi-Fi standards used in homes and many business is 802.11n, which offers or nowadays we also have ANB, which like 802.11n A, I believe, which offers serious throughputs in the range of hundreds of megabits per second, which is fine for file transfer. But one thing to consider is that it could be too much of time consuming for IoT applications, like IoT hardwares, which have power limitations. And a series of radio frequency development kits are designed for building Wi-Fi based applications and are available from RS as a store. Anyway, it is based, of course, the standards is based on IEEE 802.11n. Frequencies could be 2.4 gigahertz or 5 gigahertz. Range approximately 50, but then again, it depends on the router, and also if you choose to increase the range, you could also use repeaters, and data rates could go up to, I mean, of course, it's at a higher data rate like Mbps, larger Mbps, and it could go up to Gbps even, right? Then there's a cellular network. So 2G, well, 2G was not capable of IoT. Then came 3G, even that's not capable. 4G, 4G to some extent is capable of larger applications, but now slowly and steadily in the coming years, I mean, in the coming years we'll see 5G, which is typically designed for IoT communications, and 5G has passed its research phase, and now it's in the implementation phase. Various countries across the globe have started implementing 5Gs, and in India, we'll soon be seeing 5G implementations as well. And 5G is typically aimed for IoT based communications. So yeah, so that's briefly about cellular mode of communications, wherein wherein we currently are on 4G. That is enabling IoT to some extent, but 5G will be used for optimizing and more smooth sets of communications as well as secured data transfer. NFC, we do find NFC in some phones nowadays, and what NFC does is it enables NFC means near field communication. It enables simple and safe two-way interactions between electronic devices, and especially applicable for smartphones, allowing consumers to perform contactless payment. I remember Sony having NFCs in most of their smartphones. Nowadays, a very few smartphones have NFC, but those that have are capable of making contactless payments using NFC. Samsung Pay, I believe, also has the option for NFC contactless payment, and NFC also allows access to digital content and connect electronic devices. It essentially extends the capability of contactless card technology and enables a device to share information at a distance that is less than 4 centimeters. Yeah, so the distance is a huge drawback, but otherwise it does allow contactless form of communications. Okay, so the standards it is based on is ISO IEC 18003. Frequency is 13.56 megahertz. Range is 10 centimeter, and data rates is 100 to 420 kbps. Then there is Sixfox. Then there's Mule. Well, Sixfox, even though it's used, well, I won't be covering Mule, by the way. And Sixfox is basically an alternative wide range technology, which in terms of range comes between Wi-Fi and cellular range. It uses the ISM bands, which are free to use without the need to acquire a license, something to note, and to transmit data over a narrow spectrum to and from connected objects. The idea of Sixfox is that for many M2M applications that run on a small battery and only require low level of data transfers, then Wi-Fi range is too short, while cellular is too expensive and also consumes too much of power. Sixfox uses a technology called ultra narrow band and is only designed to handle low power data transfer speeds of 10 to 1000 bits per second. And it consumes 50 microwatts compared to 5000 microwatts for cellular communications. Anyway, so standard is Sixfox, frequency is 900 megahertz, range is 30 to 50 kilometer. Could be utilized very well for rural environments and 3 to 10 kilometer for urban environments. And data rates are 10 to 1000 Mbps. Now coming to LoRaWAN. Well, briefly, LoRaWAN is again something similar with respect to Sixfox and Mule. LoRaWAN targets wide area network applications and is designed to provide a low power WANs, which with features specifically needed to support low cost, mobile, secure, bidirectional communications for IoT, M2M, and smart cities. So for smart cities applications, you will see LoRaWAN implementations, you will see MQTT implementations. And LoRaWAN, as it is based on Sixfox, has quite good range, and it is optimized for low power consumptions and supports large networks with millions and millions of devices. So standard is LoRaWAN, frequency could be various. Range is between 2.5 kilometers in urban environments and 15 kilometers for suburban environments, and data rates are somewhere between 0.3 to 50 kbps. As we are on LoRaWAN, let's look at this article that describes what is LoRa, modulations, and what is a LoRaWAN. Okay, so LoRa is basically wireless modulation techniques derived. Before I start this, any questions on these wireless protocols? Maybe you can put it in the chat or also raise your hands.
Yes, participants, if there are any questions, please let us know. Sukanya, could you just share one information about like how much power plays an important role in selecting the appropriate framework, that is like selection of the platforms like LoRa, 6 LoPan and others comparatively. So can you just please give one input on to this particular aspect?
Sure. Absolutely. So actually the differences can be observed significantly when it's a rural environment and an urban environment, right? So in urban environment, we can provide ample amounts of power backups, but that's not applicable in case of a rural environment always, where there's no power. Let's say take an example in the areas of Leh Ladakh, there's no electricity. Hence, it is difficult to provide power backup for heavy networks on a daily basis, right? So the alternative would be ideally to use this low power, high range networks and transmit it to a nearby edge devices, which could possibly be located edge storage or edge devices, which could possibly be located on a nearby suburbs or towns, that has little more power availability than those extreme remote areas. So again, uh, putting it one liner, it depends on the use case, and also the surrounding environment where you want to implement the sensor network. If it's a smart city area, then it's not much of a problem, right? But like in an urban area. But again, if it's a remote area, then you would need to consider other application protocols. Does that answer your question?
Yes, yes, yes.
Okay, moving on. So LoRa is basically a wireless modulation techniques, which is derived from chirp spread spectrum technology. It encodes informations on radio waves using chirp pulses, similar to the way dolphins and bats communicate. Okay, so LoRa modulated transmissions is robust against disturbances and can be received across great distances. I mean, you can read about this later, and I mean, just don't get confused with these high level terms. These are nothing but modulations and sound frequencies that they're describing. LoRaWAN. Okay, so currently we have 1.0.4 version as of October 2022. It's a protocol developed and maintained by LoRa Alliance, and what else? So the bandwidth versus range that we get here is, so they made a comparison between Wi-Fi, LoRa and cellular. So LoRa has huge amount of range. Wi-Fi does not have that much amount of range. Again, cellular has limited amount of range, but the bandwidth of Wi-Fi and cellular is on a higher level. LoRa is on a lower bandwidth. And like few brownie points for LoRaWAN is like it is ultra low powered. So LoRaWAN ends devices, LoRaWAN end devices are optimized to operate in low power mode and can last up to 10 years on a single coin cell battery. Then there's long range. So LoRaWAN gateways can transmit and receive signals over a distance of 10 kilometers in rural areas and 3 kilometers in dense urban areas. Then deep indoor penetration. So when you have multiple walls and the device needs to communicate through walls, LoRaWAN is capable of doing that. Sometimes you see when you use Wi-Fi and you have multiple walls, then in that case the Wi-Fi signals gets hindered. LoRaWAN, on the other hand, is capable of going deep in terms of indoor coverage. License free spectrum. You don't have to pay expensive frequency spectrum license fee to deploy LoRaWAN network. So it's license free, and since it is maintained by an alliance, it is open. Geolocations. LoRaWAN network can determine the locations of end devices using triangulations without the need of a GPS. LoRa end device can be located if at least 3 gateways pick up its signal. High capacity. LoRaWAN network servers handle millions of messages from thousands of gateways. Public and private deployments, of course, with LoRaWAN, it is possible it is easy to deploy public and private LoRaWAN networks using the same hardware, gateways, and end device antennas and softwares, such as UDP packets, basic station software, is also LoRaWAN stack for end devices. End-to-end security, LoRaWAN ensures secure communication protocol between the end devices and the application server using AES 128 mode of encryption. Then there's firmware update over the air. So there's over the over the air update that is applicable for LoRaWAN. So your device gets updated with just a software push over the air. Roaming, LoRaWAN end devices can perform seamless handovers from one network to another. Low cost, minimal infrastructure, low cost end nodes and open source softwares. Certification program, LoRaWAN allowances. So if you want to upskill yourself in LoRaWAN, so LoRa Alliance certification program certifies ends devices. And if you want your device to be certified LoRaWAN devices, then use the Alliance certification. Then the ecosystem, LoRaWAN is used widely, has large ecosystems of device makers, gateway makers, antenna makers, etc., etc. That makes it highly preferable choice of usage. So, okay, a few use cases. Vaccine cold chain monitoring. LoRaWAN sensors are used to ensure vaccines are kept at appropriate temperatures during transit. Animal conservations. Tracking sensors manage endangered species such as black rhinos and Amur leopards. Dementia patients. Wristband sensors provide fault detections and medication tracking. Smart farms. Real-time insights into crop soil moistures, and optimized irrigation schedule reduces water up to 30%. So it just monitors the or the irrigation system on real time and can switch on or off depending on the requirement on the thresholds set. Water water conservations. So it basically okay, so your city have pipelines of water flow, right? So what it does is, I mean, it could monitor those pipelines in real time and monitor for any leaks basis with the help of sensors, and maybe notify the respective city council for repairing purposes. Food safety, temperature monitoring ensures food quality maintenance. Smart waste bins, smart bikes, airport tracking, efficient workspaces. In your office or organizations, you can use this to check room occupancy, temperatures, energy usage, parking availability. Cattle health, of course, there are sensors to monitor cattle health, detect diseases, and forecast calves' delivery time. Also, LoRaWAN are used in space to some extent. Satellites to provide LoRaWAN-based coverage worldwide. Yeah, actually, so if you would have heard of the internet, the internet satellites that are currently being worked upon by Facebook and Elon Musk is also working on some. So the idea is to provide internet through satellites worldwide. I mean, even though we are doing this session online, but a majority portion of our country, and not just ours, African countries and a lot many others are not connected right now. So in order to actually have a complete connected world, it is essential to have that network availability as well. Okay, so moving on, there's another protocol which is quite famous, that is MQTT. So, excuse me. So what happens in case of an MQTT is, it's basically a publish subscribe protocol. So it's a lightweight publish subscribe protocol where you can publish and receive messages as a client. So node rate, let's say, is a MQTT design software. It passes the MQTT message to Raspberry Pi to another module, and basically it controls an send a command to control an output, and then you can read and publish your data back. So you publish the message and then you subscribe to the message to get the acknowledgements. Okay, and then you have basically MQTT is a simple messaging protocol designed for constrained devices with low bandwidth. So again, MQTT is used widely as it consumes low bandwidth and is capable of transmitting good amount of data. So it becomes the perfect, of course, for these reasons, it becomes the perfect solutions for IoT applications. MQTT allows to send commands to control outputs, read and publish data from the sensors, and much more. And hence, because of this, it is really easy to establish communications between multiple devices. If you like home automations and you want to build a complete home automation system, then in that case, I mean, basically MQTT is used for home automations as well as for it can also be used for irrigation systems, smart parkings. Depending on the bandwidth that you would require and the kind of use case you are imagining, you could use MQTT. And if you want to perform home automation, you can go through this course and learn. I can send you the link. Just on a high level overview. On a high level overview, basically you can send a command with a client like Node-RED to control an output, and then let's say you're controlling the bulb, and this is the temperature sensor that sends back the data to the client, again through subscription. So MQTT, there are a few basic concepts that needs to understand. First is like publish, subscribe. How does it work? Messages, topics, and brokers. So what is publish and subscribe? So this is device 1, this is device 2. The first concept is the publish and subscribe system. In a publish and subscribe system, a device can publish the message on a topic. We'll cover what topics are here, and it can be subscribed to and the device can subscribe to a particular topic to receive back the messages. So it's pretty much like, how do I explain? Let's say you subscribe to a newsletter and then you receive messages, right? So that's the subscription mode. Whereas if you directly send an email, the message directly goes to the sender. That's the publish mode. Just, I mean, don't take this example literally, but metaphorically, this is how to explain the publish and subscribe. Okay. For example, let's say device 1 publishes on a topic. Device 2 is subscribed on the same topic as device 1 in publishing in. So device 2 basically receives the message. What are messages? Messages are basically the informations that you want to exchange between your devices, whether it's a command or a data. And now finally, what are topics? So basically topics are the way to register your interest for incoming messages, or how you specify where you want to publish the message. Topics are represented with strings separated by a forward slash. Each forward slash indicates a topic level. Here basically home, office, LAMP. So home is a topic, office is a topic, LAMP is a topic. Topics are basically case sensitive, which makes these two different. So as it is case sensitive, this one is different from this one. Anyway. So here we have MQTT client device. Then we publish the message, which is, let's say, either on or off to the topic, be it home, be it office, be it LAMP. And here we have an MQTT client that has sensors attached to it. In this case, they are showing it in the form of LED lights, and it gets the message on or off. And basis this message, it switches on or off the light. And then we are also subscribed to this client. So this client will basically give us the acknowledgement. And so what's happening here is you've decided to publish on and off message on the home office LAMP topic. You have a device that controls the LAMP, and it can be an ESP32 device or an ESP8266 device or any other XYZ board. The ESP32 that controls your LAMP is subscribed to that topic, home office LAMP. So when a new message is published on that topic, the ESP32 receives the on and off message and turns the LAMP on and off from this topic. So the first device can be an ESP32, an ESP8266, or an home automation controller platform like Node-RED, Home Assistant, Domosets, or OpenHAB. And what are MQTT brokers? I have a YouTube video that explains how you can enable MQTT brokers using Node-RED. I'll just pull up that in a while. Okay, so what is MQTT broker? So basically, a broker is primarily responsible for receiving the messages, all messages, filtering the messages, and deciding who is interested in them, and then publishing those messages to those particular respective clients. Basically, publishing those messages to those particularly subscribed clients. Then there are several brokers you can use. In basically home automation projects, we can use Mosquito Brokers. Mosquito Broker is an open source MQTT broker. It is maintained by Eclipse Foundations, and this acts as an MQTT broker for publish and subscribe for publishing and subscribing the messages. Anyway, so like Mosquito Broker, which can be installed on the Raspberry Pi. Alternatively, you can also use a cloud-based MQTT broker like at present days Azure, which is the cloud offering from Microsoft, and AWS, which is the cloud offering from Amazon. They have MQTT brokers available on their IoT suite that is capable of reading those MQTT messages. To install MQTT broker on the basically, if you there's a tutorial for installing MQTT broker on Raspberry Pi devices, because Raspberry Pi devices. Okay, the first thing is to set up the Raspberry Pi devices, and then you can install the because Raspberry Pi is nothing but just a Linux terminal. I mean, it's a Raspberry Pi uses an OS which is Raspbian, which is a Linux kernel. So you'll get an interface like this, much like you use your Linux terminal from PuTTY or just the Linux terminal. Yeah, and yeah. So, any questions so far on MQTT before I pull up a demo?
This MQTT broker is available onto mobile platform also, so that if you wanted to connect to the LoRa
MQTT messages, yes.
It is available to the mobile platform also, from where you can do that. And as far as the topics are concerned, it can also be customized, I believe so.
Yes.
Depending upon the organization of the data where the sender and receivers are agrees to, you can synchronize it, or you can reformulate as per your convenience. So that is the additional point which I wanted to convey.
Right. Thank you so much for adding that. But yes, we could. Thank you.
So if there are any questions from participant side, they can put it into a chat box. No hand raise. Okay, Sukanya will continue with the work.
Yes. Is there any way where I can?
Yeah, tell me what you wanted to do actually.
Yeah. Is there any way that I can share the device audio as well?
Yeah, you can directly share the device audio. There is no problem, I hope. We can check it out once.
Okay, so that's okay.
Since we don't have any settings here that restricts you to share your device audio, there is no problem.
Oh, okay. In Microsoft Teams, there's a separate option. So let me know if you can hear this.
The Internet of Things, or IoT, is all about interconnecting devices.
It's coming.
It's coming, right?
Yeah, it's coming. It's coming.
Yeah. Okay. I'll just play this video. It shows Node MCU and MQTT setup. Just have a look.
A secure way for online devices to communicate is using MQTT. MQTT is a publish-subscribe-based messaging protocol that avoids direct connections between devices by relaying data through a central server called the broker. This is really desirable in IoT because it's easy to add new devices without touching the existing infrastructure, and since new devices only need to communicate with the broker, they don't actually need to be compatible with the other clients. In this video, I'll explain how the MQTT model works, go over some advantages and disadvantages, and finally, use it to toggle a digital output. To get an idea of how the publish-subscribe or hub-sub messaging model works, let's start with a real-life example. Let's say I have a switch connected to one device, and I want to use it to toggle the state of a light attached to another, separate device. Traditionally, I would just connect them directly. But then, if I added new devices with more lights and wanted them to be triggered by the same source, I would need more connections, and the same goes for adding more triggers. This gets very messy and difficult to maintain. Especially with IoT, you could have a whole building full of lights and switches, where each is a separate device. So instead of doing it this way, I can use the publish-subscribe system. This way, I can have the device with the switch publish the switch state under some topic, say switch, for example. Then I just subscribe to that topic from another device, and anytime a message is published with a matching topic, the broker will relay the new information over, and this device can use that to toggle a light. Now, if I go to add more lights or more switches, I just have one new connection for each client to the server, creating a nice hub and spoke model that is easy to maintain, rather than the spider web that we would traditionally need. What's more is that this only demonstrates how one topic can work between devices. You can have as many topics as you want for your application, with each one having different clients on either end, being one-to-one, many-to-many, or any combination. The pub-sub architecture is very flexible and scalable, making it great for IoT applications. Now, let's make this a reality. Here, I have a Groove Epic edge programmable industrial controller that has a light hooked up to it. I can use the screen to toggle the light. I'm not always going to be standing right next to the device. So, I'm going to set up the Groove Epic to be an MQTT client that is subscribed to a specific control topic to toggle the light based on the messages that come in on that topic. Then, all I need to do is publish to that topic from my laptop, which is a separate client, and I'll be able to control the light from anywhere in the world. To control the light, I'll be using Node-RED, since it has a basic MQTT client built in, and it's running on the Groove Epic right out of the box. To find out more about either Groove Epic or Node-RED, check out opto22.com. Now let's get that client set up. To get to Node-RED, I just go to my hostname /Node-RED. Then I just proceed through security and log in. I can drag the subscription node in right away and double-click it to edit its settings. This example, I'll be using the public broker, and in my case, mqtt.groove.com. Here you could use a broker running on a local device like your Mac, Linux, or Windows PC, a Raspberry Pi, or a cloud service like Amazon Web Services. The default secure port for MQTT is 8883, but I'll just be using the insecure broker port 1883. Many brokers are encrypted or password protected, but this one is open to the public, so I'll leave username and password blank. The final settings screen shows 3 additional optional messages: birth, death, and will. I'll come back and set these up later once we know everything else is working. So now with the broker set up, we're almost ready to subscribe. The next thing to look at is the topic. The topic namespace is an unmanaged way to identify your messages. I say unmanaged because there is no enforced format or standard to follow. Each client determines the topic of that device's messages, which means you, as the programmer, have to be consistent and specific with your topics, and you'll need to share it with anyone else that interacts with your broker, since they'll need to know what to subscribe to and what to publish to. This is a lot of freedom, but I'll keep things simple for this example and just use workshop/switch, where switch is called a subtopic of workshop. I could have workshop itself be a subtopic of something larger, or I could just publish directly to the topic switch, but that's going to depend on your application. Next, I can choose the quality of service, which is a big part of MQTT. In short, it determines how much of a guarantee of delivery you want for your message. 0 quality of service means that the broker will receive the message at most once, but might miss it since there is no confirmation made. Quality of service 1 means that the broker will receive the message at least once, but may get duplicates while it's waiting for confirmation. And finally, quality of service 2 means that the broker will receive the message exactly once. The highest quality of service sounds the most attractive, and for control purposes, it is really the only option worth considering, but it does come at the cost of extra network traffic, since the broker and client must exchange confirmation packets, particularly for quality level 2, since both sides have to acknowledge the publication. Now, with my subscribed client all set up, I'll need to use this switch message to toggle a line. To do that, I'll use the SnapPack write node. These are used to interface with the I/O modules installed on the Groove Epic chassis. This will just connect to the localhost device, since Node-RED itself is running on the Epic, and I'm going to be writing to the digital output I have set up on the system strategy called panel red LED. And that's all there is to set up. If I wanted, just for testing, I could also add a debug node to double check the output here as well. Now, with my Node-RED flow all set up, I'll hit deploy, and now I just need to publish to this topic to test it out. To do that, I'll be using a separate client running on this laptop called MQTT.fx. Once it's loaded, I just bring up my server list and I can go ahead and add the broker. In this case, it'll be the same public broker that I added to Node-RED. It's at mqtt.groove.com, and I am using the insecure broker port 1883, and I'll not be putting in a username or password since it's open to the public. Now I'll just hit apply, close this window, and connect to the broker. Now all I need to do is publish to that same workshop/switch topic and give it a message. And in this case, I want to turn the switch on, so I'll send the message true. Now all I have to do is publish, and the light comes on. Fantastic! The connection is both sound and very fast. And if I were to use my own broker, I can encrypt the data and securely password protect it too. In this case, the publishing client is my laptop. This represents the switch. It publishes the switch state up to the broker, and then the broker relays that message down to Node-RED on the Groove Epic, where it makes the control decision to turn on the light. So now that we know everything is working, let's take a quick look at some of the more advanced features that I skipped. Birth, death, will messages, retained topics, and finally, wildcards. So if I go back to Node-RED and bring open the broker properties, I can see those three messages, birth, death, and will. Like the Node Info tab says, these messages are sent whenever this device connects, disconnects, and is forcibly disconnected from the broker. For example, I can have the birth message public under the topic workshop/status and give it the payload online, since that will be the status once this message is sent. Because I want this to arrive at least once, I'll give it the quality of service level 1, and I'll turn the retain flag to true. You'll see what this does in just a moment. Similarly, with the close message or death message, I can say offline, since when I successfully disconnect, the workshop status will be offline. I'll give it the same quality of service and retain flag. Now, with these two messages set up, I can just listen to this one workshop status topic, and I'll be able to track the state of this device as it comes on and offline. But if it drops unexpectedly without sending a disconnect message, I want to know that too. This is handled by the will or last will and testament message. This message gets sent by the broker if this client ever unexpectedly disconnects. So in this case, I'm going to use that same workshop status tag and give it the payload disconnected, since it is an abrupt disconnection that causes this message to be sent. Now, I'll save these new settings, deploy, and head over to MQTT.fx to subscribe to this message. What's great about the retain flag for MQTT topics is that I can now subscribe to this status, and I'll get the message right away when I connect because it was set to retain it. Now the broker will keep track of the latest copy of this tag to come in, retain that data, and send it out to anyone that comes and subscribes to this topic. While I can't use this feature to request the state of the device at any time, it does mean that new devices to join the system are aware of the health of all the other clients that are already connected. So now, to test this out, if I go and make a change to my Node-RED flow and deploy, that should mean that this client disconnected and reconnected. And if I go back to MQTT, I can see that a disconnect message went through and let me know that my device was offline, and then it came back up and I got another message. Finally, I want to see the last will and testament. So to test that one out, I'm going to try and use a wildcard. A wildcard is essentially a way to select any matching topic. For example, if I wanted the status of every device, not just the workshop, I could replace workshop with the single level wildcard plus. And what this does is plus will replace anything that matches a subtopic status. So if I subscribe to that, I'll be getting both a copy of the workshop status and a copy of the developer status, which is another machine running in the building. The other thing I can do is subscribe to workshop /# or the pound character. This is a multi-level wildcard that will match all subtopics of workshop, including both switch and status. And if status had any subtopics, it would get those as well. It's also possible to get everything matching every single topic by just using a single multi-level wildcard on its own. But this gets a little bit loud, so it's usually not recommended. I'll unsubscribe from these topics and just use that single level wildcard plus/status to test the last will and testament. When I subscribe, I see the retained messages come in. Then, when I unplug the Ethernet cable in my Groove Epic, it disconnects from the internet, and the broker lets all the subscribed clients know that this device has dropped. This disconnected here is that last will and testament message. Using this, it's possible to monitor the health of your various devices and even have a system in place to alert you when something is down, attempt to reboot it, or shift that device's responsibilities over to another system. And there you have it. There's a quick run-through of MQTT and its place in the Internet of Things. To learn more, check out Opto.
So just saw how Node MQTT client is used to create the MQTT brokers and topics and make it up and running. Of
Yes,
course.
Sukanya.
Yes.
Sukanya.
Yeah.
There is a framework called TTN. So the Things Network, it is called the Things
yes.
Network.
Yes.
Yeah. So if you look at the TTN, it has a broker configuration also.
Right.
The way the brokers have been configured here, it is being configured on TTN also. So,
Right.
So in what way, like how this has been migrated from TTN to this particular platform? Like, is there any special reason for migrating this from?
No.
TTN?
It's much like MQTT is the standard. MQTT is the foundational protocol, right? Using its principle, we have Things Network, we have ThingsSpeak, we have various cloud providers dealing with IoTs, we have Node-REDs dealing with the MQTT. So it's like, there's no difference as such. It's just that many organizations are implementing the same foundations in their own specific way, right? How do I explain? So let's say when it comes to IDE, integrated development environment for programming, right? You have many IDEs on the market, right? But the general principle of integrated development environment is to help you code, right? And it's just that Visual Studio Code, Android, Google Android Gradle, there's PyCharm, there's Eclipse. They're all coming up with their own IDs. It's up to you, to your preference, what you would like to use. And of late, the modern ones are coming with cloud enablement as well. So, so to answer your question briefly, like there's,
Yes.
no, we are not trying to change the frameworks. It is all existing for you. it just depends on your personal preference and the requirement of the project. Which one would you like to go ahead with?
But we find that TTN and MQTT, if you configure together, it is pretty easy than
Yes.
dealing with other frameworks.
Yeah, but I unfortunately did not find any good tutorial on the Things Network, at least on YouTube. But I believe there are a couple of blogs on the Things Network regarding MQTT, right?
Yes.
Yeah. So yeah, I mean, there's not much on the internet at this point of time, but yeah, I mean, definitely there's also something called ThinkSpeak. If you have heard of, um, ThinkSpeak, I think ThinkSpeak MQTT. So yeah, I mean, there's also something called IFTTT. I believe that also enables you to do MQTT. So again, it depends on the platform of your choice and of course the feasibility. Like for cloud providers, simple example, we have 3, 4, I guess we have hyperscalers, which are like Azure, AWS Cloud, Google Cloud, and then there's DigitalOcean, then there are others, right? But it again depends on the feasibility. I mean, in terms of UI accessibility, Azure and Google Cloud are quite user friendly, and that's why people who have little understanding or little uh, people who are from a non-technical background usually go ahead with those to get started with, right? Uh, so it's pretty much the same, but the underlying basic foundational concept remains the same for all the frameworks. It's just that whichever one wants to make it more user friendly and whichever one wants to keep it native that way, that matters. That's it. Anyway, so moving on to the next one, I believe I wanted to show you Zigbee. But then again, okay, so this is setting up a home automation system with Zigbee. But before that, if I could show you how Zigbee works. So interfacing Zigbee with Arduino, if I may show you this one.
Hello friends, in this session we will learn how to configure Zigbee as a Zigbee coordinator and Zigbee end device. Once we configure these two devices, we will establish communication between these two with the help of Arduino.
So one thing to remember here is
Also, everyone watching. Now what is
one thing to remember here is the protocol is Zigbee, but this hardware module is known as XBee. That's the difference. Don't get confused.
now what is Zigbee? Zigbee was intended for embedded application. There will be no constraint of data rate, but there is a high constraint of power consumption. Zigbee is using IEEE 804.15.4 based specification, which is suitable for wireless personal area network. Nowadays, there are some new models which are supporting UART as well as SPI communication. Zigbee operates in industrial, scientific, and medical, that is a ISM radio band, which is working at 2.4 gigahertz. As it is giving two options, that is UART and SPI. Compared with the UART, SPI is having larger speed. Now, role of Zigbee is in single network. Zigbee can play three different roles. First one Zigbee coordinator, second one Zigbee router, and third one is a Zigbee end device. Zigbee coordinator. Zigbee coordinator is responsible to establish the network. It will select particular channel as well as PAN ID, and it will distribute the addresses to the router as well as end devices. It will allow routers and end devices to join the network. Zigbee router. Zigbee router can join existing network which is created by Zigbee coordinator. It will receive the information, it will save the information, and it will give proper path to the information. In case any Zigbee end device is in sleeping mode, it will save the data in its buffer. In single network, there may be multiple router or single router. Zigbee end device, that is ZED. ZED can join existing network and it will send and receive the information. It will not allow any other device to join the network to this ZED. Network can be composed of one and only one coordinator, one or more than one router, and one or more than one. Now Zigbee network. Zigbee coordinator will create the network and it will allow ZED to join the network. In case Zigbee coordinator want to increase its range, in that case, it will allow any router to join the network so that through router it can communicate with the ZED. And the number of ZED will be connected to the ZC or ZR. In our case, we are going to create a network with one Zigbee coordinator and one Zigbee end device. In our case, transmitter side is a Zigbee coordinator. Receiver side is a Zigbee end device. Arduino Nano is the source of information, and the laptop is the destination of information. This information will pass through Zigbee. To make Zigbee as a coordinator or Zigbee as an end device, we have to do some settings with the help of one software. The settings for coordinator are PAN ID. In my case, I have chosen as a 111. CE coordinator enable 1. Destination address DH must be equal to 0. Destination address low DL is equal to FFFF for broadcast mode. Node identifier. It is an optional thing. Here we are giving name to particular Zigbee device. In my case, I am choosing name as a master. ZWave channel verification must be disabled. API enable, that is transparent mode 1. For Zigbee end device, settings are PAN ID, which is already given for a Zigbee coordinator. Same PAN ID we have to use. In my case, it is a 1111. Next one, CE coordinator enable must be disabled. Destination address DH must be equal to 0. DL is equal to 0000. And node identifier, it is again name. Here I am giving name as a slave. It is an optional thing. Next, JV channel verification must be enabled so that it can join existing network. API enable must be transparent mode. Here are my two devices. I am connecting one of the device to my laptop, so it will get energized. Similar way, other device also I will connect to my laptop. Now two devices are energized. Now I will open software XCTU to configure these devices. One XCTU software window is like this. After connecting Zigbee model with our laptop, discover this model. Right now it is showing COMP1, COMP3, COMP10 port. Click on next. Keep this setting as it is. Baud rate 9600, data bit 8, parity bit none, stop bit 1, flow control none. Finish it. It has discovered two models. So add these selected devices. Suppose I want first device as a coordinator. Select PAN ID which we have discussed, that is a 1111. Click on pencil icon which will write this setting. Next one is a ZWave channel verification. It must be disabled. Write this setting. E coordinator must be enabled. Write this setting. Next, DH0 and DL must be again 0. destination address 0, and DL must be FFFF NI node identifier. That is the name we are giving. I will say it is a master. Write this setting. Afterward, API enable. It must be transparent mode. API enable must be transparent mode. It is already there. In this way, I have to make setting for the coordinator. Similar way, we will make setting for the Zigbee end device also. Similar way, click on second option and select PAN ID as a 1111. Write this setting. Similar way, make all necessary changes which we have discussed. Now you will be ready for data transmission. Now there are two devices. First one is the master, which is connected through COM port. Second one is the slave, which is connected through COM port. I will disable one of the device, close it, and now for remaining module, open console, and now click on open button so that we can show that there are two devices which are communicating with each other. So use another software, that is a Flash Magic, and we will open second device by using Flash Magic. So go to the tools, terminal, config. Now suppose if I am giving any information by using first device, this information is received. Similar way, if I am writing any other information, same information will be received by using another. So in this way, we have established communication between two devices. We have formed the network. Interfacing of Arduino with is acting as a transmitter in our case. These are two Zigbee modules. This Zigbee module is the interface with the Arduino, and this Zigbee module is connected to the laptop. The small program is written for Arduino. This program will send hello world string towards the receiver. After that, will send counter value only after 1 second. Now I will upload this code in Arduino. Now code is uploaded. Now we will observe the output by using Zigbee module. To observe result, connect Zigbee module with a laptop and open CTIoT software. Search our Zigbee module and now click on console. Once you click on console, now open terminal. Now I am energizing Arduino. Once I energize Arduino, it starts sending the information. Now you can observe the information in this console. Hello world, counter 1, counter 3, and so on. That is our entire module in which we have learned how to configure Zigbee. We have written code in Arduino to transfer the data from Arduino to laptop.
Okay, so this was about configuring Zigbee between Arduinos and computer, but you can also use the same procedure to the modules. The XP modules could also be configured with other hardwares, and like I had tried doing it between Node MCU and Arduino. Then you could also do it between Raspberry Pis. Right. Okay, so you could also use Raspberry Pis and configure those XB modules and then configure this Zigbee thing. And there are other projects using Zigbee. You could use home automation projects for with Zigbee. You could create those home assistants. There's another video on creating home assistants, but I think we don't have time. The remaining 6 minutes, I probably would give time to you to ask me any questions or anything that you would like to know or discuss on IoT. applications and protocols, anything that you are working on or mildly related to your interest field. So please go ahead and just leave this forum for 5 minutes for you to interact.
Yes, participants, if you have questions, please raise the hands so that I will unmute you and you can ask the question to the expert. Or you can write it into a chat box as well.
So how was the session? Was the session at all helpful?
Yeah, session was excellent session. In fact, it has covered the topic which are actually mostly required, right? The best part of the session was about providing a virtual platform for the beginners to start with their work, because in most of the cases, I have seen students struggling for getting the resources. Like they don't have an access to the sensors, they don't have an access to the boards as such, and they give up in they give up the course, like they don't want to proceed in that way. So the platform which you have discussed, providing a virtual mode for them to start with the uh, at least begin with the concept of understanding sensors, playing with the sensors, and likewise. So in that way, it is really very helpful. As far as this LoRa and TTN and MQTT part is concerned, this is really beneficial for the people who has got some kind of experience into developing a platform, developing an application actually. So for them it is quite good. Overall the session was very informative. Yeah, as far as student points of view is concerned, if you have any questions about feedback, I will share the feedback link into the classroom. Don't worry about that. If I know that it has created some issues, so I'll share that feedback link into the classroom. Don't worry. Moreover, if you have any questions here to have an interaction with, we
Yeah,
can go ahead.
I think there's a question in the Q&A section. So, so there's a question on how can one interface two sensors with I2C protocol to one Arduino. So, this question is from Madhavi Gambhir. So, Madhavi, if you remember, I had shared. Okay, let me just open up that and show you. Okay, so if you remember these diagrams, if you connect, you remember Arduino had two SDA SCL pins. Arduino pin out. Okay, let me open the pin out. Yeah, so Arduino has two SDA SCL pins, right? So you can use these two pins for interfacing two sensors, or else what you can do is, I showed you the this thing, the breadboard configuration, right? So some fields of the breadboard are in parallel configurations, and some fields are in series configurations. So you can put the SCL and SD in those, and accordingly use those serial pinholes to interface the sensors. So let me pull up a breadboard image. Yeah. So if you look at this image, So this A B C D E F G H I J. So these are A B C D E is in series, F G H I J is in series, and here these are plus is in series, minus is in series. So you can put the SDACL, pull up the Arduino from there here, and then use this 4 pins to interface both of these, at least 4 sensors at minimum, or 3 sensors here, and you can short these 2, and then again another 4 sensors here. Does this answer your question? Madhavi, you could just reply on the Q&A section itself if that answers your question. Or maybe you can unmute yourself.
Yeah.
Yeah, okay, thank you. Any further questions? You can put it in the chat. Q&As. Unmute yourself. Okay, great. So
There is no questions.
if you have any, I mean, you can always get in touch with me over LinkedIn. So my LinkedIn is pretty much, I mean, just search Sukanya Mandal on LinkedIn, and you should get me if you want to further discuss anything. Or else,
Sukanya, there is one more question in QA.
okay. Can we connect Arduino to Pi? Yes, with I2C and with SPI, both. You can connect Arduino to Pi.
Yes.
Any further questions?
No, I think there are no questions right now into a chat box. There's
Okay, no problem. So we see each other on 29th again then.
29. Yes, 29. So thank you very much, Sukanya, for sparing your time for this particular faculty development program, and we would like to see you on 29 for your session on to IoT and AI. So thank you very much. Thank you very much, Sukanya, for your time. Yeah.
Thank you so much. Thank you all for
Yes.
patiently
Thank you.
listening. Thank
Yeah.
you.
So, so as far as this present feedback is concerned, don't worry, you'll get a feedback link into your classrooms. There you need to give your feedbacks, and we will have henceforth I'll share the feedback links into. I thought to share this here initially, but it was like getting completely mess. You turn into means you get deeply involved with the feedback and you leave the content. So I decided to make it available to you into the classroom, and henceforth you will find session polling session polls in each of the sessions, so you can poll it out, and that will be in last 10 minutes where Q&A is going to happen, and you have to fill in your feedback into the classroom. Okay, that's it for the day, and our last session, third session, will be at 3 o'clock, where the robotic engineer from Robocart is going to deliver the discussion on to Raspberry Pi and programming with sensors and actuators. Okay, so would like to see you at 3 p.m. today in the next session. The links will be available into the Google Classroom. Till then, we'll stop here. Have a good time. Thank you.